So today we are going to discuss about comparison between SN1 and SN2. So let's draw a curve to understand this comparison. Here we have a curve. Here we have SN2 priority. Here we have SN1 priority. Here we have SN1 priority. Here we have SN2 priority. So when we have CH3 and methyl leaving group, then the SN2 will be the priority. SN1 will not be the priority. When we have RCH2N 1 degree, then also SN2 will be the priority. That's how the curves look like. Then the priority will be SN2. But when we have RCHL, then R 2 degree alkyl halide or 2 degree substituent, then we have both the priority could be there. SN1 and SN2 depends on the strength of the nucleophile. Then if we have R, C, L, R and R, when we have 3 degree, then SN1 is the priority. So that's how we see what are the priority. 1 degree and methyl SN2, then SN1, and in 2 degree it could be both SN1 and SN2. We have substrate over here. The substrate first we have CH3Cl. Whether it will show SN1 or SN2, I'm writing here, and here also I'm writing substrate. Whether it will show SN1 or SN2. Let's dig deep into it. So CH3Cl. CH3Cl won't will give SN1 and will give SN2. Steric crowding 1 degree methyl carbocation is not possible. CH3 or CH2Cl not 1 degree and will give 2 degree. Third, CH3F. It won't even 1 degree and 2 degree because it is a poor leaving group. CH3 or CH3 or CH3 and Br. It will show 1 degree but not 2 degree. Fifth, CH3 or CHCl, then CH3. Now it is 2 degree, it could show SN1 and SN2. If we have weak nucleophile, it will show SN1. If we have a strong nucleophile, it will show SN2. Sixth, we have CH2 double bond CH and Cl. It won't be giving SN1 and SN2 both because it is the lone pair is going into the resonance. So it is a very poor leaving group. Seventh, CH3 or CH, CH2CH and CH and Cl. It will give SN1 and SN2 both. Eighth, when we have weak nucleophile like water, alcohol, it will give SN1, and when we have strong nucleophile like iron, I minus, Cn minus, it will go through SN2. It could be PHOH also, a lot of examples could be there. When we have chlorobenzene, then it won't be giving SN1 and SN2 because again chlorine is going in resonance. Lone pair of chlorine is going into the resonance with benzene ring. So it is very difficult to break this bond. Ninth, CH2 or Cl. Again it will be weak in case of weak nucleophile. It will show SN1. In case of a strong nucleophile, it will show SN2. Tenth, we have this bridgehead chlorine. Bridgehead chlorine can't give SN1 neither SN2 because the inversion is not possible in case of SN2 and bridgehead carbocation doesn't exist due to Brett's rule. We have seen the Brett's rule. It will go SN1 and SN2. SN2 because of steric crowding less. SN1 because it is a plus M stabilized carbocation. CH3 NH B NHCH3 Br. Again it will show SN1 and SN2 both. Let's look 13th. This compound CH2 or Cl. It will go SN1 and SN2 again. It is a dancing resonance, a lot of things. This compound chlorine. This compound will not show SN1 neither SN2 because again The bridge hand carbocation is not possible, and inversion also not possible. 15 CH3. CH3 C CH2 Cl, then it is CH3, then it is CH3. So not mean weak nucleophile and a strong nucleophile. 1 degree carbocation is not possible, and then steric crowding is there. So SN2 is also not possible. 16 Cl. So it is not 1 degree and 2 degree SN2. And as a non-aromatic compound, carbocation is not possible. So it will follow the SN2. This compound. Br. It is a SN1 and SN2 because it is an aromatic compound. When Br leaves, the carbocation form aromatic, and it is a 2 degree also. So now let's understand this topic with the help of lots of various examples. Now we have to compare the rate of SN1. Compare rate of SN1. First we have chlorine, second we have bromine, water here and water here. Both are same, but Br is a good living group, so that will be the answer. And this was A. B. We have chlorine 1 molar, OH minus 1 molar. We have this chlorine 2 molar, OH minus 1 molar. So again, B1 and 2. 2 is because the concentration, the RDS involved the SN1, the RDS involved the concentration of that substrate only. See, OH minus then H2O, Cl, OH minus and H2O. This is 1 molar. This is 1 molar. This is 1 molar. This is 2 molar. So what will happen? The rate are equal. First equals to second, because the rate doesn't depend on concentration of reacting species. It only depends on the concentration of reactant. D. Chlorine H2O. First, second. PHCl H2O. Now, second is a very bad living group. So answer is first. pH, CH, Cl and CH3. It is 100% water. Second, pH, CH, Cl and CH3. It is 80% water and 20% ethyl alcohol. So answer is 1. It is 100% water. Because 100% water, the polar, it is affected by solvation. We have seen the solvation effect, right? So the 100% compound will be alcohol. In second case, it could be alcohol also, and it could be ether also. But the rate of reaction will be more in case of when we are getting the single compound alcohol. F, CH3O, CH2, CH2 and CH2Cl. And when it reacting with water. Second, CH3O, CH double bond CH, CH3, CH2, CH2 and Cl. Water. So the rate is more in case of first. The rate is more in case of first, because that carbocation, the forming is quite far from the minus I group. Here carbocation forming is quite near to the minus I group. So it is first rate. Now we have to detect the product. Next question. We have pH, CH2 and Cl. We are reacting it with water, ethanol, RC double bond OH, PHOH, H2S. So it forms PHCH2OH plus HCl. PHCH2OC2H5. We all know what is the attacking species and what is the answer. I'm just writing the answer. You have to solve by your own. C double bond O R plus HCl. PHCH2 OPH then HCl. PHCH2 SH then HCl. So this is the answer. Now let's compare the next question. Compare the rate of SN1. A we have CH2Cl, then we have CHCl. B. Third we have CCl. So what happens when Cl goes, Cl removes, it is 3 degree, then it is 2 degree, then it is 1 degree. B. OTS. This is OTS is attached with a carbon, right? Now it is we have CS3 group. That is also the resonance group. So what happens? We know that it is a dancing resonance. When it gets the carbocation over here, the carbocation will flow into the compound, and it will, when it reaches the meta position, para position, then it shows dancing resonance or sigma resonance. Due to dancing resonance, the first compound is very stable. But in the last case, there is no dancing resonance, or there could be dancing resonance. Just think, in the first case, when then the carbocation is there, there is dancing resonance. But in second case, when the carbocation is here, right? When the carbocation reach on the para position, when it show dancing resonance, so it won't show dancing resonance, or it can show dancing resonance. I'm asking. Okay, let's see. It is a good question. The carbocation is here. Okay. So yeah, what happens due to that bulky group? This ring comes out to the plane. This is plane, then it comes out to be 90 degree to the plane, outside the plane. So it won't be showing a dancing resonance. So first we'll be showing the dancing resonance. For the dancing resonance, it obviously has to be in the plane, same plane. Next we have CH3, then OTS. OTS and this group. So first we'll having, when carbocation is the para position, it will having 3 alpha, but the second compound having only plus I effect. So the hamper conjugation is more than plus I. Now we have to complete the following SN1 reaction, or complete the following reaction. We have HCl, CH3 and pH. We are reacting with water. So we know it is a stable carbocation because resonance stabilized, and it is 2 degrees, so it could be SN1 or SN2, but we have a weak nucleophile, so it is SN1. So in case of SN1, in the racemic mixture will form. It could attack on the both side. Let's see the second question. We have this chlorine and H2O. So again it is SN1, so it will form OH. C we have phenyl group. It is attacking with bromine. It is forming CH3OH with. So bromine will be replaced like this. These all are very similar type of questions in this order to practice. Okay, OCH3, this compound will form. Now we are asking the last question, but not the least. Compare the rate of SN2. In my question, I have really a lot of examples. A lot of examples. You won't be finding anywhere such examples. So question: compare the rate of SN2. First, BR, BR, BR. So we know 1 degree is SN2 more than 2 degree than 3 degree because steric crowding. BR, BR. We know in this case this is near and this is far. This is providing the steric crowding and remaining part are same. So the rate will be first. Third, we have BR and we have BR. So rate will be more in case of second because again less steric crowding. We are comparing the rate of SN2. The attacking species must be a strong nucleophile. Fourth question is like Cl here and Cl here. First, if I name it second, so where the species will attack? If we have OH minus 1 equivalent, so it will attack over the second one because it is a less steric crowding. Next, fifth, again we have one equivalent of OH minus. We have chlorine here and chlorine here. We have OH minus only. It could be more than one equivalent, but replaceable chlorine is only one OH. Chlorine and chlorine. Sixth, we have chlorine OH minus. So it will be replaced like this. Seventh, we have a Sawhorse projection. It is reacting with SH minus. So HDSH, HDCH3. This will form. It will CH3 will replace OTS because it is a polar leaving group. This is the deuterium. Polar leaving group and it will show SN2 and inversion will be there. Let's solve some more questions. This is videos mainly focused on question. This particular video, we have this hydrogen, deuterium, and phenyl. It will react RS minus Na plus. It will show SN2. So it will forming deuterium, hydrogen, and RS. Hydrogen, deuterium, and pH. Right, it will show inversion. Next question we have hydrogen, chlorine, CH3, ND. Reacting with the NaCN forming SN2 reaction, showing SN2 reaction SCN, HCH3 and D. Next question we have pH, H, D and Cl reacting with NaSH, showing SN2 reaction pH, C, H, SH and D plus Cl minus. Next question. It is reacting with this compound. So it will show SN2 reaction. This will replace this nucleophile, will replace this leaving group. So it will showing SN2 reaction. Next question. plus Cl minus will also liberate here. Here we have Cl, Cl and Cl, and here we have O. This is an excess. So it will replace with CH3OH, react with CH3OH. So this carbon cation will move because it is showing plus M. I suggest you just try all the questions by your own. Just pause the time when I do the solution. ClH and D and H. It is reacting with I minus, showing SN2 reaction in CH3OH solution. I minus in CH3OH solution. So in SN2, the chlorine, the iodine, chlorine will be replaced by iodine, but it is axial and it is equatorial. It will go into equatorial, and it was axial because inversion takes place. Deuterium and hydrogen will remain same. And the last question of this topic. Question we have. Here we have chlorine. We have CH3. Here we have deuterium. Here we have hydrogen. This is chair form. It is going CH3OH and SN1 mechanism. It is flowing OCH3, then CH3. Deuterium and hydrogen will remain same. Deuterium and hydrogen will remain same. And for forming CH3 and OCH3, because it is SN1, it will showing racemic mixture.